Hey everyone, today I'll be presenting a paper on TripCraft, which is a high fidelity benchmark for spatio-temporally fine-grained travel planning. This is a work from researchers at IIT Bhubaneswar and Microsoft India, and I found it really interesting in how it advances the evaluation of AI agents in the travel planning tasks. Let me start by framing why the authors argue that travel planning agent is such a challenging problem for AI systems. Think about planning even a simple trip. You're not just picking destinations randomly, you're simultaneously juggling four major competing objectives that all need to work together perfectly. First, there is scheduling. You need to align opening hours of attractions, coordinate flight times, and manage check ins properly. Then there is budgeting. You have a very hard financial constraint that and need to balance spending across flight, accommodations, food, and also other fun activities. Third is routing. You have to maximize the travel time between locations to avoid inefficient back and forth movement. Finally, there is personalizations. The plan needs to align with what the traveler actually wants to do. The key insight the authors wants to present here is that these aren't independent goals, they are deeply interconnected. If any of these fail, the entire itinerary essentially collapses. It is like a house of cards where removing any piece brings the whole structure down. This makes automated travel planning a particularly demanding test of AI systems' reasoning capabilities. Now, the paper identifies significant limitations in existing benchmarks like travel planner that reduced their real world applicability. Let me highlight the main issues the authors found. First, the data quality problem. These data sets rely on semi synthetic data, which led to some absurd inconsistencies. For example, travel planner placed New York City hotels across 312 different cities. Obviously, not realistic. This kind of spatial hallucination makes it hard to trust the benchmark. Second, there are critical missing constraints. Real travel planning involves public transit schedules, event availability, and timing considerations that these benchmarks simply ignore. Without these constraints, agents aren't being tested on realistic scenarios. Third, authors emphasize on this as very crucial. The current evaluation methods use binary validation. A plan either passes all the constraints or fails completely. There is no nuance, no ability to say that this plan is better than that one, even neither of it is perfect. The gray area between a perfect plan and a completely broken one is where the most real planning happens, and the existing metrics completely miss this part. So authors built TripCraft to address these gaps. This is a comprehensive benchmark built entirely from real-world data covering 140 US cities. Let me give you a sense of scale. They created around 1,000 carefully constructed travel queries, scraped over 3.4 million real flight records, and gathered nearly 22,000 events, including concerts, sports, art performances, and mapped more or less 8,720 public transit stops with actual schedule information. This dataset covers three trip durations: 3 day single city trips, 5 day trips visiting two cities, and 7 day trips that covers three cities. This progression in complexity allows testing how well agents handle increasingly difficult multi city coordination challenges. Importantly, each query comes with gold standard reference plans that are created through a rigorous annotation process involving 25 graduate students and multiple rounds of expert review. This ensures high quality data for ground truth evaluation. The construction pipeline. Let me walk you through how the data set was actually built because quality control was absolutely critical for this work. The process started with web scraping to gather data from TripAdvisor, Airbnb, Ticketmaster, and GTFS transit feeds. But raw scraped data is messy and inconsistent. So there were intensive cleaning and validation steps to remove hallucinations and fill the missing values. fill the missing values appropriately. For query generation, the authors use GPT-4o to compose natural language queries that incorporate all the constraint and persona information in a realistic way. The annotation phase was most intensive part. The 25 annotators created detailed itineraries, and crucially, they provided justifications explaining their reasoning for each and every plan. This went through multiple feedback and refinement loops where domain experts reviewed the annotations for both feasibility and optimality. The experts combined automated validation scripts with a manual review to catch issues that pure constraint checking would miss. The paper notes that this entire pipeline took significantly more effort than prior benchmarks, about 30 minutes per instance versus much less for simpler dataset. But the result is reference plans that are truly realistic and high quality. One of the key innovations in this work is moving beyond simple demographics to model what actually matters for travel preferences. The authors deliberately do not include age or education level, as this can introduce bias without adding any meaningful information. Instead, they focus on four persona components that truly shape travel planning. Look at these two example personas. The laid back traveler wants relaxation, luxury, and nature. Their schedule shows late breakfast at 10 a.m. and a long 3-hour museum visit and generous time between activities. In contrast, the adventure seeker is economical, thrives in cities, and packs their day. More or less like an 8 a.m. hike, a very quick lunch, kayaking, and multiple activities with very minimal downtime. These visual schedule comparison make it clear that persona isn't just a label. It fundamentally changes the structure and paces out the itinerary differently. A good planning agent needs to recognize and adapt to these two different travel styles. So let us look at the set of constraint framework that makes TripCraft a very realistic and challenging benchmark. On the hard constraint side, there are strict requirements that must be satisfied. Budget adherence is non-negotiable. Room type matters. Entire room versus shared room is a real distinction that travelers care about. Event categories span sports, art, music, and film. And critically, there are 15 diverse attraction categories, ensuring plans don't just visit museums repeatedly, but they include varied experiences. Then there are common sense constraints. These reflect practical human considerations, something like a meal gap that at least requires 4 hours between breakfast, lunch, and dinner, because that is realistic eating pattern. Valid POI sequences means you must start and end each day at your accommodation and cannot visit an attraction after your departure flight, and you also need reasonable buffer timings. The route logic prohibits teleportation. You cannot jump between two different distant cities without a valid transportation. And diverse events mean no repeating the same concert or game multiple times. Together, all these constraints create a planning problem that actually resembles real world travel complexity. So, this is where the work fundamentally rethinks the evaluation metrics. Traditional approaches ask, did it pass or fail? But that's not how we evaluate or judge a travel plan. Even human made travel plans cannot be on point. So, a plan isn't just valid or invalid, it exists on a spectrum of quality. The authors introduce 5 continuous metrics scored from 0 to 1. The temporal meal score is the first one. It checks if meal happens at natural time. Is breakfast actually in the morning, and is it at a reasonable hour? That is what this notes down. The temporal attraction score evaluates whether visit durations make sense. Are you spending an appropriate amount of time at each attraction, or are you rushing through in 15 minutes? Spatial score measures the transit efficiency. How far are each of these attractions from nearest public transit? Are you making it impossible for human beings to walk between the transit and the tourist attraction. That's what this score evaluates. The fourth one is ordering score. This assesses logical sequencing. Does the itinerary flow smoothly or does it jump between two distant locations? And persona score. This captures the alignment with user preferences. Does this plan actually match what an adventure seeker versus a relaxation focused traveler want? So, the beauty of continuous scoring is the nuances captured by it. A plan scoring 0.7 on meal timing is much better than a plan scoring 0.4 on it, but none of it is perfect. This gives us a much richer signal for understanding the agent performance. So let us see the mathematical rigor behind these metrics. Let us start with temporal modeling. For temporal meal score, the authors use bivariate Gaussian distribution because meals have both a natural timing and a natural duration. More or less like when should breakfast occur and how long should breakfast last. They model these jointly with a correlation between time and duration. This allows smooth penalization. A breakfast at 9:40 scores higher than the one at 11 a.m. and this in turn scores higher than the one at 1 p.m. For temporal attraction score, they combine a Gaussian for visit duration and a Poisson distribution for number of attractions. This is persona aware. An adventure seeker has a higher expected number of attractions, while a laid back traveler has very fewer. The expected duration per attraction dynamically adjusts based on how many total attractions you are visiting and your traveler time. The key insight is that these distributions are learned from human annotations. The parameters, the mean standard deviations and correlations were computed directly from how annotators had structured their plans. This grounds the evaluation in realistic human planning behavior. The spatial score uses a distance decay function. If a point of interest is like within 5 kilometers of transit, the score decreases linearly. Beyond 5 kilometers, it decays exponentially because distances become increasingly impractical. This reflects the reality being this reflects the reality that is more or less like being 2 kilometers from a bus stop is workable, but being 250 kilometers away is like completely infeasible. Authors have observed this in few of the plans that were generated from AI agents. For persona scores, the authors leverage semantic matching through BERT embeddings. They compute cosine similarity between persona components like luxury and adventure, and the names of point of interest visited. Why names? Because point of interest often embed rich descriptors, more or less like luxury spa retreat or extreme mountain climbing. This captures alignment much better than just category matching. The ordering score uses edit distance between generated sequence and the reference sequence. This is normalized to a 0 to 1 scale. This measures how much reordering would be needed to match the ideal itinerary flow. For their experiment, the authors tested GPT-4o across all three trip durations. They compared two settings that reveal something important about how to guide LLMs for planning. So, in the standard setting gives the model the task, the constraint, and an example, but relies on its common sense for reasoning some things like meal timing, meal duration, and etc. But the parameter informed setting additionally provides explicit distributional guidance in natural language. Something like breakfast is ideally scheduled at 9:40 and it lasts about 50 minutes. Adventure seekers kind of like visit 2 to 3 attractions per day. This tests a very key hypothesis that has been in the research community. Can we improve planning by making implicit expectations explicit? The generated itineraries that are generated go through the TripCraft evaluation engine that computes all the metrics that were described earlier. Looking at the results, it reveals a fascinating tension. Look at the left panel that is showing the continuous metrics. When parameter information is provided, the quality improves substantially. The temporal score literally jumped from 0.61 to 0.80 for a 7-day trip, and which is a 31% relative improvement. And spatial efficiency and persona alignment also improve between these two. Now, look at the right panel showing traditional constraint-based metrics. The pass rate actually drop when parameter information is added. For 5-day trips, the common sense pass rate falls from 60% to 30%. So, what exactly is happening here? The authors suggest that by giving the model explicit optimization targets, it tries harder to hit the ideal meal timings and visit durations. But this rigid adherence sometimes conflicts with other constraints, leading to some violations. This reveals a fundamental challenge. A model struggles to balance continuous quality optimization with discrete constraint satisfaction. So, while looking at the 7-day trips, the pass rates are very close to zero in both the settings. This shows like longer multi-city itineraries planning like remain really challenging for even frontier models. So let us discuss about some specific failure models that authors discovered that highlight why TripCraft is valuable for understanding the current limitations. One is temporal hallucination. The model schedules visiting an attraction after the departure flight has already left. This shows a temporal failure. This shows a failure to reason about temporal dependencies. If you depart from a place at 1:05, you cannot visit that place from 1 to 2 in the afternoon. The second one is commuter's nightmare. An accommodation is like placed 250 kilometers away from the nearest transit stop. This reflects a profound spatial reasoning failure. The model knows to include nearest transit but does not understand that 250 kilometers actually defeats the entire purpose. It's not able to get that 250 kilometers is like very huge distance. So this third one is persona mismatch. For an adventure seeker persona, the plan includes only one museum visit and nothing else that day. This is too slow paced for someone seeking thrills and activity. The model is not adapting its planning density to traveler type. So these aren't edge cases. They represent systematic reasoning failures that continuous metric can detect and quantify, but binary metrics would miss the degree of the problem. So, what I love about this paper is that authors are very upfront about the limitations of these papers. They say that currently events, most of the events aren't included in the main POI list because they lack structured start and end times. They only know the date. If detailed event timing data becomes more available, it can also be integrated along with the dataset they have created. The dataset covers around 140 US cities, and this is what GTFS transit data availability allowed the authors to do. The construction pipeline is designed to extend internationally, but that requires transit schedule data for other regions as well. Most importantly, the authors note that their goal wasn't to propose a novel planning algorithm, but during while trying to work on the same, they were able to they built a data set. They enhanced the itinerary generation format, and they also created fine-grained evaluation metrics to enable the research community to develop and test better planning approaches. TripCraft provides a rigorous benchmark that future methods actually need. Um, So, let me conclude by emphasizing what TripCraft actually achieves. The work moves from binary to continuous evaluations. So, plans are not just valid or invalid, they have measurable quality across multiple dimensions. This enforces a spatio-temporal realism through actual transit schedules, real event data, and geographic consistencies. And it enables persona alignment by modeling actual travel preferences rather than including irrelevant demographics such as education, qualification, or gender. Um, The underlying principle is very simple but powerful. Better benchmarks build better agents. By providing a realistic, rigorous evaluation framework, this work sets a new standard for what means to succeed at AI driven travel planning. As the results show, the current state of the art model still struggles significantly with this task, but with this task, this is especially visible as the complexity increases. But TripCraft gives us tools to precisely measure where the failures have occurred and how and a way to track progresses as the field advances. Thank you so much.